Welcome back to Graphing Quadratics in Standard Form. We now have two more examples that we're going to do of graphing. I already have some of them set up just so that way I'm not wasting time getting it all written down. But here we go. So our next example, graph the equation y equals negative x squared minus 2x plus 8. Again, we must plot 5 points, including the roots and the vertex. So my a value is negative 1, my b value is negative 2, and my c is 8. So we're going to find the vertex first, which we start with axis of symmetry. So x is equal to negative b over 2a, which is going to be 2 over 2 times negative 1, which is 2 over negative 2, which is negative 1. We're now going to plug everything into the original. So negative 1 squared minus 2 times negative 1 plus 8. Remember, just plug everything you see here into your calculator, and we get 9. So our vertex is going to be negative 1, 9. So I'm going to plot that right now. So negative 1, 9. Again, I'm going to label it with a V for vertex. Now it's time for our roots. And again, roots are the same thing as x-intercepts. I'm going to use both words, and we're going to use the quadratic formula. So we have 2 plus or minus the square root of negative 2 squared minus 4 times negative 1 times 8 all over 2 times negative 1. Simplify underneath the square root and in the bottom. So we have 2 plus or minus the square root of 36 all over negative 2. And now we take the square root of 36, and that's going to be 6. So since it's a perfect square, we can now break it apart. So 2 plus 6 all over negative 2 is 8 divided by negative 2, which is negative 4. So our point is negative 4, 0. So I'm going to go and graph that. Next, 2 minus 6 all over negative 2. So we have negative 4 over negative 2, which is 2. So that point is 2, 0. So 2, 0. Finally, our last 2 points are going to come from the y-intercept. Remember, our y-intercept is 0, and then the c value, which is 8. So we're going to plot 0, 8. And then, remember, we reflect over the axis of symmetry. So it's only one space away from the vertex, so we go one space the opposite way. So now we have our lovely U shape that we are now going to carefully connect. And there we go. All right. So last example, and then we will be done with our lesson 11 notes. All right, so we want to graph y equals x squared plus 10x plus 24. So my a is 1, my b is 10, and my c is 24. So again, we start with finding the vertex. X equals negative b over 2a. So negative 10 over 2 times 1, which is negative 10 over 2, which is negative 5. And then my y value, we plug it in, so negative 5 squared plus 10 times negative 5 plus 24 is equal to negative 1. So my vertex is going to be negative 5, negative 1. So let's plot that. Negative 5, negative, other way. Negative 1. I'm going to put my V there for vertex. Next, my x-intercepts. We use the quadratic formula. So we have negative 10 plus or minus the square root of 10 squared minus 4 times 1 times 24 all over 2 times 1. So negative 10 plus or minus. Simplify everything underneath the square root and in the bottom. So it's going to be the square root of 4. And then we take the square root of 4, which is going to be 2. So we now split them apart. Negative 10 plus 2 over 2 is equal to negative 8 over 2, which is negative 4. So negative 4, 0 is our first x-intercept. So negative 4, 0. Then we have negative 10 minus 2 all over 2, which is going to be negative 12 over 2, which is negative 6. So our next intercept point is negative 6, 0. And there we go. So now for our y-intercept. Again, it's going to be 0 and then the c value, which is 24. But if you notice, my graph does not go up high enough on the y-intercept to plot 0, 24. So that may be the case where you run into a y-intercept you can't graph. So instead, this is what you need to do. If the y-intercept is too large, select two x values on either side of the x-intercepts and find their y values. So we're going to create an old school table, an x and y table of values. So we want to pick an x on either side of the x-intercepts. So negative 4, I'm going to choose negative 3. And then from negative 6, I'm going to choose negative 7. And then all you're going to do is plug it back into the original and find their y. So when we plug negative 3 into the x's, we get positive 3. When we plug negative 7 into the x's, we also get positive 3. So now we are going to plot these points because our y-intercept was too large. So negative 3, 1, 2, 3. Negative 7, 1, 2, 3. So now we have our 5 points, and we can connect as a U shape. So that's the only thing you have to realize. If your y-intercept is too large, you need to select two other x values to plot instead. But we are now done with graphing in standard form.